to discuss the problem of NCERT, and the problem belongs to the chapter of electric charge and field, and the problem number is 1.25 of additional exercise. I am going to read the problem. The problem is that there is an oil drop of 12 excess electrons and it is at rest, that means stationary, under a constant electric field. The electric field is constant and the value of the electric field is 2.55 into 10 to the 4 Newton per Coulomb. In Millikan's oil drop experiment. This one is the experiment performed by the scientist Millikan, and using this experiment we can find the experimental value of the electronic charge. The density of the oil is 1.26 gram per cubic centimeter. As per my knowledge, the density of the oil which is given in this problem is wrong. If the density will be taken as 1.26 gram per cubic centimeter, then this density will be greater than the density of water. And if the density of the oil will be greater than the density of the water, then oil cannot float on water, right? The correct density of oil which can be taken will be 875.3 kg per cubic meter. This one is the correct density of oil. I am going to take this density of oil which is given in the problem, although it is wrong. What is the problem? We have to estimate the radius of the drop. First of all, I am going to discuss the approach of this problem. As the drop is stationary, that means the net force acting on the drop will be equal to 0. What are the different forces that will act on the drop? One is the weight mg, which will act vertical downward, and another one is the force acted by the electric field. Obviously the drop is at rest and the weight mg is acting vertical downward, hence the force acted by the electric field on the drop must be vertical upward, and that force will be equal to Q into E, where Q will be the charge on the drop and that will be equal to 12E, and E is the electric field which is given in the problem 2.55 into 10 to the 4 Newton per Coulomb. As the drop is at rest, hence QE minus mg will be equal to 0, and from this we can calculate the value of mass m. That mass will be written as in the terms of density into volume, and the volume of the drop is 4/3 pi r cube because the drop is spherical, and from this we can get the value of radius of the drop, right? This is the approach of this problem. Now I am going to discuss this problem in detail. This one is the oil drop, and this drop has the 12 electrons. The magnitude of the charge on the drop will be given by Q equal to Ne, and N is 12 and E is the electronic charge. This will be written according to the quantization of charge principle, right? The drop is under the constant electric field and the drop is at rest. Now I am going to draw the free body diagram of this. Free body diagram of the drop is this one. Here you can see that there are two forces acting on this drop. One is the weight mg, which will act vertical downward by the earth. As the drop is at rest, hence the force acted by the electric field on the drop must be upward, and this force will be given by QE, where Q is the total charge on the drop and E is the electric field. You can see that the drop is negatively charged, and hence the electric field must be downward such that the force acted by this electric field on this drop will be upward, right? As the drop is at rest, hence we can say that QE minus mg will be equal to 0. Right? Or you can say mg minus QE equal to 0. QE minus mg equal to 0, and from this we can write down mg equal to QE. M equal to rho V, and the volume will be 4/3 pi r cube. Now place this value of mass m in this expression, right? You can get the expression from which we can calculate the radius of the drop. Value of mass m in this expression, and after placing you can get this expression. After placing the value of mass m, rho into 4/3 pi r cube, you can get this expression. As the value of Q equal to 12E, and place this value Q equal to 12E, simplify the whole thing and you will get the radius R will be equal to 12 into E is the electronic charge, capital E is the electric field which is given in the problem, into 3, right? Divided by 4 pi rho G raised to the power 1/3. And from this expression you can get the value of radius of the drop by placing the value of electronic charge 1.6 into 10 to the minus 19 Coulomb, 1.60 into 10 to the minus 19 coulomb. Place the value of electric field 2.55 into 10 to the 4 Newton per coulomb. Density of the oil is 1.26 gram per cubic centimeter, which will be converted into kg per cubic meter. Multiplying this by 1000, you can get the value of density in terms of kg per cubic meter, and place the value of G equal to 9.81 meter per second square, right? You have to write down the value of pi equals to 3.14. After placing all these values, you can get the value of radius of the drop 9.81 into 10 raised to the power minus 7 meter, right? Which will be converted into millimeter, and it will be equal to 9.81 into 10 raised to the power minus 4 millimeter. Every data has a significant figure equals to 3. You have to keep in your mind while doing the calculation, right?